Hello students, welcome back to our channel Diksha Karnataka. So COMEDK mock test 3 has been released. So in this video, I'll be discussing the solutions of chemistry part 2 which consists of question number 31 to question number 60. So I hope all of you have downloaded the question paper, solved the paper and then you have to come here to check the solutions. Okay, so there's no point of just seeing the solutions without attempting the paper. So it is my sincere request to all of you, please attempt the paper honestly in exam conditions to understand your level of preparedness for the exam. Okay, so now if you haven't downloaded the question paper yet, the question paper PDF is available in our WhatsApp channel and the link of the WhatsApp channel is there in the description section of this video. So please join the channel and then download the question paper, solve the questions and then come back to check the solutions. Okay, so let us start with the first question here, that is question number 31. For this question is actinoid contraction is greater from elements to elements than lanthanoid contraction because. So we know in actinoids there is 5f orbitals, in lanthanoids there is 4f orbitals, and 5f have a poorer shielding effect than 4f due to its bigger size. So that is why 5f electrons themselves provide poor shielding from element to element. Okay, correct answer is option number A. Okay, now coming to next question, 60 gram of urea was dissolved in, okay, this is dissolved in 9.9 moles of water. If the vapor pressure of pure water is P01, then the vapor pressure of the solution is. So the question is from your solutions chapter, colligative properties, right? So what happens here, whenever you add any solute to the solvent, the vapor pressure of the solvent will decrease, right? So we have this formula, P0 minus P by P0 is equal to mole fraction of the solute. Now if you see here what was added, urea is added to water, right? So I can write this one as number of moles of urea by number of moles of water, right? In general, this number of in the denominator is neglected in this formula, right? So now if you see number of moles, the molecular mass is 60, given mass is 60, so number of moles of urea is 1 divided by, we have here 9.9 moles of water and then again 1 mole of urea. And here we have here P0 minus P and by P0. Okay, so now if I solve this one, I'll get 1 by 9.9 plus 1 is 10.9, that is equal to P0 minus P, okay, by P0. So now if I solve this equation, I'll get 10.9 P0 minus 10.9 is equal to P0. Okay, so now we can take this one to this side, we will get 9.9 P0 is equal to 10.9, right? I hope the calculation is correct here. Okay, so here we got the equation 10.9 minus 10.9 is equal to 10.9, P is there, right? This P is there, is equal to P0. So now if I get here, this value will come here. So 9.9 P0 is equal to 10.9 P. So now if you solve this one, we will get, we need the answer in terms of P0, right? So P0 value we have to calculate. If the vapor pressure of the pure water is P01, then the vapor pressure of the solution is. So we have to calculate the P value, right? So P value will be equal to 9.9 P0 by 10.9. Okay, so the correct answer for this question will be 0.9 P0. That is option number C. Okay, now coming to the next question, acetone on distillation with concentrated H2SO4 acid. So this reaction might not be known to everyone and here the common names are given. So if you know acetone, it is very strong oxidizing agent, sorry, dehydrating agent. So what happens when you react with this one, okay, so and it forms a compound that gives you, this product is formed, okay, after dehydration. So now this product is called as your 1,3,5-trimethyl benzene, or we call it mesetyl oxide. Correct answer for this question will be option number D. Now coming to the next question, the half-life period of a radioactive element is 20 days. What will be the remaining mass of 100 gram of it after 60 days? So if you remember, first order, all the radioactive decays are first order reaction, and half-life of a first order reaction do not depend on the initial concentration. So 60 days means how many half-lives are there? There are 3 half-lives here, right? So if we start with 100 gram, after the first half-life it will become 50, After the second half-life, it will become 25, and after the third half-life, it will become 12.5. So the correct answer for this question will be option number C. Now let us see the next question. On the basis of information available from the reaction, 4 by 3 Al plus 3 by 2 O2 gives Al2O3. Delta G is minus 827 kilojoule per mole. The minimum EMF required to carry out the electrolysis of Al2O3. So now from this reaction, if you see Al2O3, right, in that aluminum is plus 3 oxidation state, so it gets converted to Al. So in this one, we need 3 Faraday of electrons, right? So I can say for 1 mole of aluminium 3 plus, the number of moles of electrons required is 3 Faraday. Now if I want to calculate for 4 by 3 moles, because in this reaction we have 4 by 3 moles of aluminium. So for 4 by 3 moles of aluminium 3 plus, we will require 4 by 3 into 3, that is 4 Faraday. Okay, so N factor is 4. Now you have to calculate the value of delta G minus NF E naught of the cell. Okay, so the question is the minimum EMF is required. So minimum EMF required will be delta G by NF, right? So we can substitute the value. What is the value of delta G given? Minus 827 kilojoule. Okay, I'll write up. One second. So we have this formula. Delta G is minus 827 kilojoule divided by N is 4, okay, into 96500. Okay. So you can convert this kilojoule to joule. So once you convert this, the correct answer you will be getting around is 2.14 volt. That is option number A. Okay. Now next question. The reaction C6H5ONA plus CO2 plus H2O gives C6H5OH NaHCO3. This suggests that. So CO2 and H2CO3 you can convert it as carbonic acid. Now if you see here, the carbonic acid, okay, has replaced the sodium of this one and has given H plus. So carbonic acid is a stronger, we can say is a stronger acid than your phenol one. This is a phenolic salt or the salt of phenol. So carbonic acid is a stronger acid than phenol. That is why it is able to replace the sodium ion. Correct answer for this question will be option number B. Now let us see the next question. So we have given the heat of reactions are given, we have to calculate the formation of acetylene. So if you want to calculate the formation of acetylene, first you should write the required reaction. So the required reaction is we want to form C2H2, right? So for that we need 2 carbons and 1 H2, right? That will give you C2H2. So you must remember the elements must be in there, the reactants must be in their native state, okay, and 1 mole of the product should form. Now what I want is, you can see in this first, in my required reaction 2C is there in the left hand side, and in the first equation also 2C is there. Now if you see H2 is there, in my second reaction also H2 is there. I need C2H2 in the product side, but in my third reaction H2O2 is there, C2H2 is there in the left hand side. So I will convert it and I will reverse the third reaction. So what we can do is, we can add this one, 2C plus 2O2 gives 2CO2, and we have this reaction H2 plus half O2, okay, gives H2O. For this third reaction you reverse it and then add, okay. So if you reverse the third reaction, we'll get 2CO2 plus H2O gives C2H2 plus 5 by 2 O2, okay. Now you add these two reactions, okay. Now if you see 2 CO2 we can cancel, H2O and H2O we can cancel, right? And next what we have here, you can say 2 plus 1 by 2, that is 5 by 2 O2 and 5 by 2 O2. So we will get the reaction 2C plus H2 gives C2H2, right? This is the reaction that we required here. Now what we have done, so we have simply added 1 and then we have added 2 and we have reversed the 3 value, right? Minus of 3 value. So if I put the values here, minus 767, okay, and then we have minus 266, and the third one I will reverse, so it will be plus 1290 kilojoule, okay. So now if you solve this one, you will be getting the answer around 257 kilojoule, that is option number C, okay. Now let us see the next question. The ease of dehydration of alkyl halides follows the order. So if you have remembered, alkyl halide dehydration follows the carbocation mechanism. Stability of carbocation, so 3 degree, 2 degree, 1 degree. Correct option is option number D. So let us see the next question, that is question number 39. Gastric juice contains 3 gram of HCl per liter. If a person produces 2.5 liters of gastric juice per day, number of antacid tablets each containing 400 milligram of aluminum hydroxide needed to neutralize all the HCl produced per day. Okay. So now if you see here, we will be calculating here the like according to the question, every 1 liter, or I can say 1 liter of gastric juice, okay, 1 liter of gastric juice contains 3 gram of HCl. Now, a human body in an average on a particular day produces 2.5 liter of gastric juices. So, 2.5 liter means it will be 7.5 gram of HCl. Okay. Now, this HCl is what we can say is neutralized by aluminum hydroxide, and in each tablet there is 400 milligram of aluminum hydroxide. Now, first let us write the reaction between the aluminum hydroxide and HCl. So, if this will react, we will get aluminum chloride plus water. Okay. So, to balance it, I can put 3 and here also 3. So, according to this equation, 1 mole of aluminum hydroxide reacts with 3 moles of HCl. Now, let us find out the number of moles of HCl here. So, number of moles of HCl will be given mass, that is 7.5 by molar mass is 36.5. So, if you solve this, we will be getting around 0.2 moles. Right. Now, if you see in the question that 3 moles of HCl reacts with 1 mole of aluminum hydroxide. Right. Now, if I solve this one for 0.2, so 1 mole will react with 1 mole of HCl will react with 1 by 3 moles of aluminum hydroxide. Right. Now, if we have this one 0.2 moles, right? So, 0.2 moles of HCl will be equal to 0.2 by 3 moles of aluminum hydroxide. Right. So, now what is the total number of moles of aluminum hydroxide? That is 0.2 by 3. Now, we can convert it into mass. What is the mass of this one? So, if you solve this one, aluminum mass is 27, okay, and we have 16 plus oxygen is 16, 16 plus 1 17. So, 17 into 3 will be 51, right. So, now if we add this one, we are getting around 68 gram, okay, 78 gram. So, aluminum hydroxide is 78 gram. So, what I can say here from this, one second, sorry. Yeah. So, now if you see here, we have this one is aluminum hydroxide mass is 78 gram. So, we will convert the mass of aluminum hydroxide. So, mass of aluminum hydroxide will be 0.2 by 3 into 78. So, that is your 3 to the 6, then we have 26. So, that is your 5.4 grams, sorry, 5.2 grams, right. So, we have here, we will write it properly. Yeah, 5.2 grams of aluminum hydroxide is required. Now, if you see this tablet, in every one tablet, so 400 milligram if I want, then we need 5.2. For 400 milligram, we require one tablet, right? According to the question, this is one tablet contains 400 milligram, or I can write 4 milligrams. 0.4 gram is present in one tablet. So, for 5.2, how much it will be required? So, 5.2 divided by 0.4, right, that is equal to 14. So, we will be requiring around 14. So, correct answer for this question will be your answer number C, that is 14 tablets. Once again, I will repeat this question if you haven't understood. See, 1 liter of a gastric juice contains 3 gram of HCl. In the body, it is producing 2.5 gram of gastric juice. So, total amount of HCl is 7.5 gram. So, how much moles of HCl is present? Number of moles of HCl is 0.2 moles, right. Now, according to the stoichiometry, 3 moles of HCl will react with 1 mole. So, 1 mole, 3 moles of HCl is reacting with 1 mole of aluminum hydroxide. 1 will react with 1 by 3. 0.2 moles will react with 0.2 by 3 moles of aluminum hydroxide. So that means to neutralize this much gram of HCl, we require 0.2 by 3 mole of aluminum hydroxide. Now we can calculate the mass. What is the mass of aluminum hydroxide required? So just if you see the molar mass of aluminum hydroxide is 78. So 0.2 by 3 into 78. So we will get around 5.2 grams, right? So now if you see, we have to just calculate here what is the in 400 milligram, that is one tablet, then 0.4 or we can say 0.4 gram is one tablet. So for 5.2 grams it will be 5.2 by 4, so somewhere around 14 will get. Correct answer for this question will be option number C. Okay. Now next question, the osmotic pressure of 0.1 molar aqueous solution of NaCl is dash osmotic pressure of 0.1 molar aqueous solution of glucose. So if you see, osmotic pressure is I into C into RT. So if I calculate for NaCl, I value is 2 and C value is 0.1, so that is 0.2. Now if you see for glucose, it is 0.1. So see, RT will get cancelled, so it is almost doubles, right? So correct answer for this question will be option number D, that is nearly double. Now coming to the next question, solubility of a gas in a liquid increases with. So if you increase the pressure and decrease the temperature, solubility will increase. Correct answer is option number C. Next one. Okay, so this is about again coordination compound. So EDTA, we know it is a hexadentate ligand. Ethylene diamine. So if you see, ethylene diamine structure is like this, right? So here it is two donating sites are present, so it is a bidentate ligand. Now diethylene triamine. So if you see here, diethylene triamine structure is, you have like this. Okay, so there are 3 amine groups and we have 2 ethyl groups. So here 1, 2, 3. So there are 3 donating sites. So it is a tridentate ligand. This is also correct. Now if you see triethylene tetraamine. So here the structure is, we have 4N, okay, and in between these two we have 3 CH2 group. So here the number of donating sites are 4, but it is given tridentate. So that is why it is incorrect. Correct answer for this question will be option number C, that is only 4. Now next question. The major product obtained when tert butyl bromide is heated with sodium ethoxide. So if you have tert butyl bromide and then you heat it with O minus ET, so it will do elimination reaction and will get a double bond product. Alkene formation will be there, right? So this is your 2-methyl propene. So correct answer for this question will be option number A. Had this been what we can say a primary alkene, we could have got a ether as a product. Okay, next question. The correct order of increasing acidic strength of the following compounds is. So acidic strength, if there is any electron withdrawing group, acidic strength will increase. If electron donating groups are there, acidic strength will decrease. So if you see here, CF3 is an electron withdrawing group, so it will increase the acidity. So third will have the highest like A, B, C, D. So C will have the maximum, so we can eliminate these two. Now if you see OMe group, here also it will act as a minus I effect because there is no resonance. So electron negativity of oxygen will pull the electrons. So after C it should come B. So we can eliminate this option. We have C, B. Now considering A and D, so here there is more inductive effect, like more CH3 groups are there. So more inductive effect will be there and more destabilization of the conjugate base compared to here. So after C, B, then A and D. So correct answer for this question will be option number C. Now next, which one of the following contains ionic, covalent and coordinate bond? So if you see here NaCN, the structure is like this, right? So this between the attraction between Na plus and Cl minus is your ionic bond. There are 2 like covalent bonds between C and N and 1 dative bond or coordinate bond between C and N. So the correct answer for this question will be option number C. Now next one, in the following decomposition reaction, what is happening? Okay, if you see here, H plus is getting, from H plus to H is getting converted to 0. So it is undergoing reduction. Hydrogen is reduced. Oxygen is from -1 to 0. So oxygen is oxidized. So hydrogen is oxidized is wrong. Oxygen is reduced is wrong. So correct answer for this question will be option number C. Now next one, which of the following metal ion has the highest tendency to form a complex? So we know the D block elements have the highest tendency to form complex. Out of the options you can see cobalt is the only D block element here, tech transition element here. So the correct answer for this question will be option number B. Next, which of the following 0.1 m aqueous solution is likely to have the highest boiling point? So if you see delta TB is equal to I into Kb into m, right? So now once the I value, if it is highest, then the Kb value will also be higher. So the correct answer, if you see here, the I value is 3, I value is 2, and here I value is 1, here also I value is 1. So 3 is there, so highest boiling point, correct answer will be option number A. Okay, now let us see the next question. For the rate law for the reaction is given to you already. The rate constant for the reaction is given. If the concentration of NOBr is also given, then what will be the rate of reaction? Nothing to do, just we have to put the formula and calculate. So 1.62 is there, and then NOBr is 2 into 10 to the power of minus 3 square. So I'll get 1.62 into 4 into 10 to the power of minus 6. So if you can see 4 2s are 8, 4 6 are 24. So we'll get 6.48 into 10 to the power of minus 6. That is your option number D. Correct answer is option number D for this question. Direct, very easy question. Next one, the order of reactivity towards the nucleophilic substitution reaction among the compound is. So now this one here you have to be careful. So you have to understand, if a nucleophile wants to attack to these compounds, so these compounds should behave as a good electrophile. Now electrophile, how it will behave if the electron density is less. So for that we need electron withdrawing groups, right? So now if you see option number 4, there are 3 electron withdrawing groups, NO2. So this one will be most likely to react with the nucleophile because its electron density is the least. Now comparing to here, we'll get 2 here and we have 1 here. And NMe2 here is an electron donating group. So it decreases the electrophilicity of the ring, and as a result of which the reaction with the nucleophile will decrease. So we have the order here as first will be 4, then 3, then 2, then 1. Correct answer for this question will be option number C. So now let us see this question. Which one of the following is wrongly matched? Okay. So if you see copper CuNH3, it is a strong field ligand. So there will be pairing of electrons. It will have dsp2 hybridization, as a result of which the shape is square planar. Now NiCO4, CO is a neutral ligand. That is correct. Now FeCN6, if you see, Fe is having +3 oxidation state. So it is having 3d5 configuration. So if we have the electronic configuration like this, so we'll get 3d5 is in this ground state. Now when pairing of electron takes place, we will get this one, right? So it will get paired up. So this d electrons, these d orbitals are free, and the hybridization is d2sp3, and this one is given as sp3d2. So that is why it is incorrect. Correct option for this question will be option number C. Okay, next. Okay, in Lassine test, the sodium extract of an organic compound containing both nitrogen and sulfur on treatment with FeCl3 produces a blood red coloration due to the formation of, so that is due to this formation of iron cyanide, that is thiocyanide. Correct answer is option number D. Next, calculate the reduction potential of a half cell consisting of platinum electrode immersed in 2 molar Fe2 plus and 0.02 molar of Fe3 plus. Okay, so we have this one. So Fe3 plus is getting reduced plus 1 electron to Fe2 plus. Okay, now the concentrations are given accordingly. Fe2 plus is 2 molar and Fe3 plus is Fe3 plus is 0.02 molar. Okay, now if I want to write the reduction E naught of this cell or E naught half cell, so E will be equal to E naught, which is, I will mention first the formula, minus 0.059 by 1 log of product concentration by reactant concentration. So product concentration is Fe2 plus and reactant concentration is Fe3 plus. Now if I substitute the values, E naught is 0.771 minus 0.059. Okay. Now if you see here log of, so 2 by 2 into 10 to the power of minus 2. So this one will go up. So we can select 10 to the power of 2. So we will get 0.771 minus 0.06 into 2. So I can write it like this. So I'll get 0.771. So I rounded it off to 0.06 for easy calculation minus 0.12. So we will get around 0.653 or like around 0.65. So the correct answer for this question will be option number A. Okay, easy one, easy calculation. Next, mercury is a liquid metal because, so mercury has completely filled d orbitals that prevents the dd overlapping of the orbitals. So there is no intermolecular force decreases. Metallic bonding is less. So correct answer for this question is option number C. Okay, next, which of the following is a non-aromatic compound? So if you see this, this structure exists in the form of this one. Okay, because of repulsions, it exists in this form. So all the carbons are not in one plane, so there is no conjugation. So this behaves as a non-aromatic compound. So correct answer is option number C. Next, the pH of the solution prepared by mixing 2 ml of HCl solution of pH 3 and 3 ml of NaH solution of pH 10 is. Okay. So this question we have to solve it. So we have HCl. Okay, its pH is 3 and the volume taken is 2 ml. So I can say pH is 3 means H plus concentration will be equal to 10 to the power of minus 3. Now number of moles of H plus from here will be molarity into volume. So 2 into 10 to the power of minus 3 millimoles. Okay. Now let us do for NaOH. Now NaOH, see, pH is given 10. That means POH will be equal to 4. Okay. That means OH concentration will be equal to 10 to the power of minus 4 molar. And volume is given to you as how much? 3 ml. Right. So what I can calculate, number of moles of OH minus will be equal to 3 into 10 to the power of minus 4. Okay. So now if I want to like make the power same, we can write it as this one I can write it as 0.3 into 10 to the power of minus 3. Right. So now what we can say is they both will react. So how many number of moles will be left out? Number of moles of H plus left will be equal to 2 into 10 to the power of minus 3, okay, minus 0.3 into 10 to the power of minus 3, because see 1 mole will react with 1 mole. So 2 moles will, or 0.3 will react with 0.3. So how much will be left out? So that is 1.7 into 10 to the power of minus 3 moles will be left behind, right? Now if you see here, we can, these are all millimoles, okay. Now the question is asking you to calculate the pH. So now this much H plus is left behind. So what is the concentration of this H plus? So concentration of this H plus is 1.7 into 10 to the power of minus 3 millimoles divided by the total volume will be 5 ml, right? So we will be getting around 0.3 something, okay. So now 10 to the power of minus 3. So if you now calculate the H plus concentration, we have to calculate pH, that is equal to minus log of, okay, H plus is 0.3 into 10 to the power of minus 5. Okay, so once you solve this, you will be getting the value you will be getting around is option number B, that is 3.5. Okay, so the correct answer for this question is option number B. Okay. Next question, for the reaction C plus O2 gives 2CO, Kp value is given at 100 Kelvin. If at equilibrium pressure of CO is equal to 10 times of pressure of CO2, then the total pressure of the gases at equilibrium is, okay. So this is very easy question. We can have Kp formula. Kp is will be equal to products pressure by reactant pressure. So pressure of CO square divided by pressure of CO2 is the reactant here. Now from the equation you can see PCO is equal to 10 times of PCO2. So we can write 10 times of PCO2 whole square is equal to PCO2. Now if you solve 100, we'll get this one 10 square and 1 it will be cancelled, we'll get PCO2 is equal to Kp, which is 63. Now if I write P pressure of CO2 will be equal to 0.63. This is the pressure of CO2. Now if you want to calculate the pressure of CO, right, that is 10 times of this one. So 10 times of this one is 6.3. Now the total pressure will be equal to pressure of CO plus pressure of CO2 So pressure of CO is 6.3 and this one is 0.63. So we will get 6.93. Okay. So the correct answer for this question will be option number B. Okay, now let us see the next question. In chromite ore, the oxidation state of iron and chromium are. So if you have remembered the structure of the formula is Cr2O4, right? So Fe is in +2 oxidation state and Cr2O4, 2 minus is the anion here. So we can say like 2x minus 8 is equal to -2. So x is equal to +3. So +2 and +3, correct answer is option number D. Okay, next question. Which of the following can possibly be used as an analgesic without causing addiction and modification? So this question is, I think, from the out of the syllabus portion, that is your chemistry in everyday life and that one. So this one will be the answer where it is paracetamol. The IPSC name or the chemical name of paracetamol is N-acetyl para-aminophenol. That is option number B. Next one. Which of the following carbonyls will have the strongest CO bond? Okay. So here you have to understand is if the metal, okay, there is a metal CO bond like this. Okay. If metal can donate electrons to this one, then electrons are donated in the empty pi star orbital of CO and the bond becomes weaker. So if the metal cannot or the donation, the tendency of the metal to donate electron to CO is less, then the CO bond will be stronger, right? So what is the point here? If the tendency of the metal to donate electrons to CO decreases, then CO bond strength increases, right? Now if you see, when can metal donate the electrons? If metal has more electrons, it can donate electrons. If metal has less electrons, it cannot donate electrons. So if you see here, metal is having plus charge, right? So that means that it is electron deficient. So in that case, it cannot donate and CO bond strength will be higher. Here it is neutral, here it is negative, here also is neutral. So charge, if the charge is more, there is less donation and there the bond strength of CO will be more. So the correct answer for this question is option number A. Okay. Okay, so these were the second part of your chemistry solutions of mock test 3 COMEDK. If you have any doubt in any question, please comment down. I'll address it definitely. And I hope you all have attempted the paper. So please comment down your scores also and understand your level of preparation and work on your weak areas from this. Okay, so that's all for this video. And if you have found this video helpful, please like, share and subscribe our channel. Thank you and all the very best for your exam.